Welcome back for the second episode of the hacking series that we're going to present on this Foscam R2C IP camera. If you haven't seen the first episode yet, definitely go back and look at that, or you might be a little lost. On this episode, we'll try to revisit dumping the flash, and then we'll also apply some OSINT techniques to try to find the Uboot password that we weren't able to just guess last time. And then we will also try to gain access to the file system if we do dump the flash. So I hope you enjoy this one, and I will catch you at the end. Well, okay. Let's just Google. Stuff. Okay, let me just clean up this desk area. It is becoming a disaster. Okay, don't need the Sealy anymore. Out of here. All right, just the machine. The device under test. The DUT. Okay. Let's see here. Foscam. So I like to search GitHub. GitHub has some good stuff usually. Foscam BIOS password issues. Oh, not BIOS, Uboot. We'd be Uboot password. This doesn't look like a Foscam, it's like a Toya. That looks like the Foscam stuff though. Hey, this looks like kind of like our board. Uboot password. You want to give it a go? Okay, let's connect the this again. I wonder if I had to come in here and enter spy stuff. I don't know. Oh gosh, now let me reset this thing. Wonder if that's why we had problems. But anyway, let's try this out. Okay, boot it up. If it still even works. Okay. Hit any key to pause now. And that password is, it's ipc.fos tilde. What? Did that work? We're in. That's crazy. Okay, so they use the same. This is definitely a different board. Ours doesn't have a so far on the edge. Huh? Foscam using the same BIOS or Uboot password. Great. Well, that was much easier than dumping the flash, huh? We could still dump the flash potentially with just this now, but okay, let's just see print env. Okay, boot command is this. Does it have boot options? So we really want to set the init variable. Serial. Let's see here. So I don't see the boot arg. So let's actually just boot in. Run boot cmd. Okay, I'm trying to find the boot args in here. Is it taking much longer? All right, I'm gonna unplug it because I don't want it to actually boot. The kernel args should be printed in. Yeah, okay, here we go. Kernel command line. Perfect. So, let's go do this again. Hit any key. ipc.fos tilde. Nice. env boot args. Do you just separate like this? Do you do equals? Hello. Let's just. Okay, that's not right. Set. Print env. Okay, so now we got boot args equals hello. Cool. So if we change the boot args to the kernel parameters, that's not the whole thing. Root weight. This is what we want. Oh, I bet it's just because it's wrapping. No, it's definitely cutting it off. What the heck? That's what we want. Why doesn't it actually print that? Root dev ram. that looks right. Okay. And if we go init equals bin sh. What? Oh my gosh, everything's all messed up. SH. Why is there an L? Okay, that looks right. Init bin sh. Run boot cmd. Let's see if that actually takes hold. Yep. Except for it didn't run. Ah, stop. It's trying to twist itself to death. It shouldn't have ran any of this. And it didn't work. Alright, let's try again. Try rdinit, which is another thing. ipc.fos tilde. ipc.fos tilde. Okay. Set env set boot args quote root weight init equal rd init spin sh print env boot cmd. That didn't seem to work either. Let's see if like changing even the like baud rate works. Maybe it's not actually reading the, no, it has to be reading the kernel parameters. Uh-oh, missed it. Okay. env set boot args. I'm going to change this to 9600. Nope. $9,600. rdinit equals bin sh. Alright, so now we should at least see that our, the console stops displaying because our baud rate is all messed up now. Run boot cmd. As soon as the kernel executes. Nope. And this thing is definitely running. I wonder if it's the whole like Android thing. Why does it have Android in here? Set equals play. Get rid of root weight. Let's just get rid of all the stuff that I don't think makes sense and try to change this to 9600. rdinit equals bin sh. Run boot cmd. Come on. I hope that the shell stops actually printing stuff. That's what we're looking for. Like that. No. Okay. What is going on? It's not taking our kernel parameters. Why? Wait, it like really isn't. Is that the latest one? Yeah. This is not our Uboot. Set env to that. Run. That is not our kernel parameters. Huh. What? Okay. I wonder if I'm supposed to use this instead of env set. That'd be pretty lame if that was actually a difference. Huh? Kernel panic. Cannot append a correct root boot option here. Are the available partitions? Let's delete the boot option. Or the root option, I mean. So set env seem to be good. get rid of all this. rdinit equals bin sh. That didn't work. So back on this website, they set the boot args to something crazy. So we got a kernel panic though. That's like, I feel like we're on the right path. But why didn't it work? Set env args. Okay, let's do this. Delete all of the stuff. Change the baud rate. 600. And just see if that changes anything. Okay, I just copied and pasted this. Okay, set env boot args. Get rid of Android boot. Change this to 9600. Okay, so I'm starting to wonder if maybe we're doing everything correctly, just that the command we're trying doesn't exist. IP apc.fos tilde. Okay, let's just try Ash instead. Okay, so let's try like ls. Oh, that's probably the problem. Let's just... Hey, it stopped and didn't segfault. Let's change our baud rate. Okay, you are 5 now because it's 9600. We did it. We got stuff. All right. So we're in the file system now. There's the password. You can Google that. Alright, so I guess that's the common password. Let's go try to join the reboots. It didn't finish, so I'm no rush. So you know what we can do? It's this. Tor. Oh yeah, that looks much better. And so at this point we can probably let it boot and then just log in. Yeah, let's do that. Better hold this thing up so it doesn't kill itself. God, it's still trying to kill itself. Oh my things. It just really yanks on those wires in there. Alright. Okay, it's still booting. Oh, geez, where am I at now? Root Tor. Why incorrect? Huh. Didn't work. Well, that's okay, I guess. Thought it would. But, well, at least we have a shell. So we know that last command worked. So let's just go run that again. PC.fs. Okay, and then we run this one. Change the baud rate. 3, 5, 2, W, 1. Cool. All right. Why didn't our password change? Let's see, password. Whoa. Changed it back. Huh. Oh, remember the line that said we're booting to RAM? The root is RAM. Yeah, I think that's the problem. We're actually not writing to the file system. But that's okay. Can we actually see the SD card on here? So we would have to write to the flash. And we don't have a way to write to the flash. Because we couldn't figure that out. Well, I'm going to call it here for today. It's been a long day. We'll come back to this tomorrow. Hopefully we can get something working. Alright, it's not even the new day, but I wanted to get back at this because I'm really bummed that the BusPirate didn't work. I don't think I can sleep tonight until I figure that out. So let's get back over here. Oops. Let me turn this camera back on. Let's get back over here to this device. And I have another BusPirate. This one's a V6, a 3.6. It actually has the labels of what the pinouts are on the front, which I think is a much better design. So I'm going to do it. Still, when I try to run the flash command, I still hear it doing the same thing. So I think it's just not getting enough power. So what I'm going to do is actually use the Raspberry Pi. I know there's a 3.3 volt pin on here and some grounds, and just try to externally power the IC with this and see if I can just bump the power up for the BusPirate. So that's what I'm going to do here. I need to find a USB cable. Actually, here's one. That's super short. USB cable. Here's one. Okay. Alright, so if I plug USB
USB cable into the wall. And into the Raspberry Pi. This doesn't even have an image in it, an SD card. But I'm assuming that it still powers up. I could be wrong. So, pulling out the multimeter too. Okay. I should probably Google what the pinout is of these things. Oh my gosh, why is there some cable in there? There we go. 3.3 is, I don't know what orientation that is, honestly. This one looks better. Okay. So, that top one is 3.3, and this bottom one is ground. So let's try this out. 0.3, okay. So what we're going to try to do here, I don't know if this is going to work well. Ground is going to be here. And ground on this guy is ground on this is number 4, so yellow. Huh, that worked out well. Yellow to yellow. Okay. And then if we take red to red, just give it more power. Okay. Terminal. Run it. Let's see. And no difference. But why? Thought that was really gonna do it. I did. Okay, well, it didn't work again. Okay, so that didn't work. I'm actually just going to try to use the Raspberry Pi itself as for the flash ROM. So let me install the Raspberry Pi imager. Imager, yeah, this thing is sweet. Okay. I'll get back to you when this Pi is up and running. All right, and we're back, and we got the Raspberry Pi hooked up. I'm gonna attach the power. Got the command pre-filled, and all I have to do is hit enter and see what happens. And it froze. Oh, might have been a dead end too. Alright, let's try rebooting this thing. Okay, Pi is up. Whoa. mod probe some stuff. Okay. And copy this. No such file or directory. Maybe I have to enable it in here. Interface options, SPI. Yes, I'd like the SPI interface to be enabled. Okay. Cool. Hey, I found a flash chip. So I wonder if we give it our full command. It didn't work. Huh. So I'm gonna try flipping data in and data out just for giggles. I'm wondering if maybe I got them backwards. Reset the device. Okay. I'm switching them back to what they were because I don't know how I would have gotten that bad or wrong. Oh, yeah, it's working. Whoop whoop. Raspberry Pi for the win. This is what I got going on. Raspberry Pi, cables, camera. BusPirate didn't do anything. Can't get them to work. Ooh! Done. Dump, huh? Wow. Well. I'm gonna power. I need to pull this off first. Let's copy that over. Pi at 10.0.10. Okay, I'm going to unplug the power to that board. Oh yeah, this looks good. Cool. looks like a file system. Sweet. All right. Now that we got that off, I want to keep going, but as you can tell, it's getting a little dark here. So now I think I can go to sleep tonight. Didn't run into this many hiccups before, but you know, the hiccups are the best part, and get to learn some new stuff. All right. Catch you tomorrow.
All right, we did it, finally. We were able to dump the flash using the Raspberry Pi. Still with hiccups, but you know, that's just how this kind of stuff goes. We were able to find the Uboot password online, which was surprising. So I guess they don't change that. So that's always a good technique to remember for hacking in the future, is sometimes you don't have to figure it out yourself. Sometimes the information's online for you there. So always remember that. And then, yeah, we also were able to identify that the OS, or the operating system, was running in a RAM disk. So our changes weren't persistent. So hopefully we'll revisit how to maybe make our changes more persistent in the future, in a future video. So tune in next week for another episode, and we're going to start analyzing this flash dump, start looking at some of the software components and how things are working on the device. We'll open up IDA Pro to disassemble some of these binaries. We'll do some reverse engineering, and then we'll try to deobfuscate the password for the encrypted update. So hopefully that sounds interesting to you, and if it does, I'll see you next Thursday.